There was a time when we bought assets, we invested in items that are things that we wanted to buy, which lasted for a few years. But as things moved forward, we want a lot of customization, and I would say more or less personalization. And then the market is also changing so fast that you can't establish a manufacturing plant which probably would continue the way it has been for a long time. Okay, so meanwhile, we see the penetration of internet. When we started a few years ago, we had hardly anyone there, but now we talk about something like 7 billion people will be connected by 2020 and 50 billion devices will be connected, right? So that goes to indicate that almost every individual item would probably have an IP address. I don't say people would have an IP address, but almost everything would eventually have an IP address. Okay, so if you look at the major trends that we see in the world today, we see that you have a lot of change from business shift to emerging technologies. So you have a lot of on-demand services. You see a connected world. Then you have blurring boundaries between segments, because what was earlier, you have seen how the traditional automotive industry has moved to a more of a Uberization of the world that's there today. Then the market is going to move towards more and more of a B2B2C, right? And then on the technology front, we see that there's the growth of IoT, which integrates, or we say it's the symphony of the three S. It's sensors, software, and services. On the other side, you have augmented reality, virtual reality growing in a big way. Artificial intelligence, I would say it's more to do with deep learning, machine learning, and adaptive learning to your needs and demands. And then when it comes to manufacturing, we also see an influx of 3D printing, and in the mobility segment, you have things like driverless cars. Okay, so if you try to look at a traditional manufacturing value chain, why would they talk about manufacturing here all the time? Because if you talk about the industrial revolutions, almost every one of us is sort of familiar with what Ford did over 100 years ago. Because, okay, there was a time when you had too much of standardization. You could buy any car as long as it was black, right? But that was the one which introduced us to the world where you could actually buy affordable products. Otherwise, until then, buying a car was something which you need to be filthy rich to be able to afford one. But that made things possible. Okay, but that has been, we have always had a conventional value chain in which you have tier 2 suppliers providing it to tier 1 suppliers, and tier 1 suppliers supplying it to OEMs. But if you look at today's world, we see that the entire ecosystem is completely changing. So if you look at it, we'll have to probably move from auto-ready components to Uber-ready components. Okay, I don't know how many of you are familiar with this. So if you try to look at how the industry has evolved, we know that in the pre-1800s, most of the power generated was mostly, most of the mechanization was through steam power, because that was the only form of power that's available. And at this point of time, you tried to use gears, pulleys, and belts to probably transmit power in some way. The entire idea of machines, in that sense, was to reduce human effort, right? And then as things moved forward, we had the second version of Industrial Revolution, which probably came towards the end of the 19th century, which also is synonymous with around the same time as Ford, though it originally started with a slaughterhouse in Cincinnati, where they wanted to use machines with conveyor belts for slaughtering animals. But this eventually moved into this first conveyor belt, which was actually introduced in the automotive segment by Ford. And at this point of time, the main focus was to improve efficiency, productivity, and quality. So this was the main thrust of it. And again, it reduced human effort further. The next phase of the Industrial Revolution was that of digitization. So here, what happened was, it gave you a lot of flexibility in manufacturing. You could have very high quality and improved productivity, mostly with the integration of what is more commonly known as integrated CAD/CAM approaches, where you could actually have software in a digital form, which was representative of the final product to be produced, and this information could be transferred to machinery, and the machinery could eventually produce what you wanted. And so that is the third phase of the Industrial Revolution, wherein you just brought in some amount of digitization. But when you move towards the fourth generation, which is also now called I 4.0, is also called smart manufacturing, it's also called connected manufacturing or connected industry. So all these words refer to the same thing. So they're synonymous with the same word, that's smart manufacturing. So here what happens is, you would have a lot of transition that happens between digital to physical to digital. And again, it also goes one step forward to probably integrate the entire ecosystem, starting from suppliers to users to finally the end customers and all of them. So the entire value chain, right from raw material to customers, is sort of integrated in this mechanism. To make the IoT, the I 4.0 a reality, of course, you require a lot of technologies which are enabling them. One of them is low-price sensors, ability to do a lot of data analytics and data mining, And now it's not a challenge because CPU or computing power is very easily available and pretty cheap. In the past, it was very expensive. Then you have a lot of decentralized networking. Then you can actually locate both indoors and outdoors the exact position of anything that goes into your manufacturing system. And then again, storage, and it's also about increase in software, hardware usability in the manufacturing system. Okay, this is just one use case to know how things work. This is just a suite of solutions which Bosch has initially started with. Of course, we have this is what is inside the plant, and then we have a short video which depicts it more in detail.
This is how the personalized information display we saw earlier will be created. Planners then determine which process modules are required for manufacturing. There will hardly be any more need for special machinery. Planning and modification cycles will be significantly shorter. The in-plant flows of supplier parts and finished parts will also be optimized. The production process starts from virtual representations. The internet-based system then puts together the ideal manufacturing line on the factory floor. An associate puts the individual modules in the correct position, or they take up their position in the line automatically. Autonomous rollers ensure efficient plant logistics. At the Competence Center at a completely different site, experts are already beginning to train identical process modules for their tasks and make the manufacturing parameters available. The modules are ready for manufacturing immediately and produce zero errors right from the very first part. Rejects are a thing of the past. The display knows which process modules it needs and maneuvers automatically to them, depending on availability and requirements. A wide variety of products now pass along a single line. The finished product is packaged and sent to the automaker. Sensors on the packaging detect the condition and position of products and transmit this information to the Bosch IoT cloud. This makes it possible to continuously monitor product quality along the supply chain in real time. Manufacturing will offer us far more than we ever thought possible. More versatility, optimum resource efficiency, and products that are more personalized than ever before. As designers, users, and decision makers, it is people who will assume the most important role in manufacturing. Industry 4.0 will drive the creation of solutions that make work a lot easier and satisfy customers' demands for tailor-made products. Bosch, invented for life.
Okay, so what we see here is you have the entire value chain integrated. So in principle, we have humans, machines, object systems are all connected in real time. And then you have every node in the value network, which is, in fact, even the object that you're being manufactured or the objects which are used in the manufacturing process, all of them would have an ID. So the moment the object moves to the machine, it tells the machine what it should be doing. And then this goes further one step and goes all the way till the end user. And suppose even to the logistics, you also have the possibility to track the condition of in case it's a perishable dish or whatever it is, you track it all the way end to end. So as a company, how we have started this journey of i4.0 was mostly by integrating these solutions mostly within our own organization, because we have around 270 manufacturing plants worldwide. So i4.0 as a first step is implemented there, and we also have some other divisions of ours like Bosch Rexroth, or we call it drives and controls, and your packaging divisions which actually make manufacturing machinery for others. So these two concepts of ours, including Bosch Energy and Building Solutions, we have integrated them to also offer or provide services across the industry. So what we had originally learned were those experiences which are eventually being transferred into offering solutions to the industry. we have fundamental challenges in implementing this. You have things like network congestion, then coping with big data analytics, then you have software system costs, then you also need to take care of interoperability, because when you're talking about different suppliers and your customers using their own individual systems, and when you have a lot of proprietary solutions built in, interoperability becomes a big challenge. So it's sort of necessary to have some kind of standardization across this. Then data security is always a threat. Then when you're having all these systems there in place with a lot of sensors generating a lot of data, who eventually owns this data? That's an important challenge that you have. But at least from the solution that we are offering, we say the end consumer is the owner of the data that he has, and he chooses what he needs to do. Then one big challenge in its implementation would be on the competency gap. The main issue here is, on one side, you need people who can implement and maintain and run the systems, and then on the other side, you also have shop floor people who actually need to adapt from the traditional ways of manufacturing into the I4.0 approach, right? Okay, here the main point I would like to say is your digital strategies have to be very context specific. You cannot take one size fits all, so it's sort of necessary to build your own or customize your own solution to make this happen. And when you're looking at solutions, you need to look at not just your customer, but focus on your consumer. That's what makes it a realistic solution. So at least in a company like ours, we have 4 major business sectors. We have energy and building, industry, mobility, and so all of them. So we're connected for the entire landscape of what's there.